Hello student, this is the exercise for the permutations when the all objects are the different. In this exercise, I had explained all the examples in a very simple language. I hope that you will understand all the solution of this exercise, and this is very big video. Now let us start the exercise 3.3. Now let us start the permutations. In this case, the order is important. Consider the problem where we want to make the words with or without meaning from the letters of the word mat. Taken two at a time under the assumptions that no letter is repeated. म्हणजे मॅट मधनं दोन आपण लेटर्स घेणार आणि त्यापासून एक वर्ड तयार करणार. It has the meaning or may not have the meaning. Now first, if we take M, then you will get A and T. If we take T, then A and M, and if we take A, then M and T. Now from when M, A, M, T, T, A, T, M, A, M, A, T, these are the total 6 words. Thus we get 6 different words from three letters M-A-T, taken two at a time. Note that M-A is not same as A-N. That is, in this formation of the word arrangement, of letters in a definite order, that is, we can take any two letters in a different arrangement in a definite order plays an important role. Such arrangement referred to as a permutation. Now see this again here. That is, in this formation of the words, arrangement of the letters in a definite order. plays an important role. Such an arrangement referred to as a permutations. You can take any two letters from MAT. It may be meaningful or meaningless. Such type of the arrangement referred as the permutations. Now we'll see the definition of the permutation. What is meant by the permutation? It is nothing but the arrangement of these objects. Now see this here. Definition. A permutation is an arrangement in a definite order of number of objects taken. Some are all at a time. Means some means what we can take we required, and at the same time we can take all the objects also. Permutation of a different object taken are at a time is the total number of ways in which an object can be arranged at R places. Now this is the important. Suppose that we have n objects, and if we take R at a time, then there will be the different arrangement of the object. Therefore, that is, suppose that if we have the 5 object, and if we take 2 from that, then how the two objects can be arranged? In this way, suppose that if we have n objects and taken R at a time, then these objects can be arranged like this, denoted by NPR. This is very important. That is, from the n object, we can take R object and taken in a specific manner. Permutations when all objects are distinct. When we take all the objects from a particular set, and all these objects must be different, the number of permutation of n different object taken are at a time when repetition of the objects is not allowed, is n into n minus 1 into n minus 2 dash dash n minus r plus 1. And now this can be written as NPR, and its formula is very simple, that is n factorial upon n minus r factorial. Thus, NPR is equals to n factorial upon n minus r factorial, where r is less than n. That is, from the n object, if we take r objects, then r object can be take the formula n factorial upon n minus r factorial. In particular, when r is equals to n, that is, there are the n objects, and we are taking again the n object from that. Therefore, the formula can be written as r is equals to n. That is the number of the permutations of n different objects taken all at a time is given by NPN, that is the n factorial n is equals to r. Thus, n different objects can be arranged among themselves in NPN, that is a n factorial ways. The number of permutation of n different objects taken r at a time when repetition of objects in permutation is allowed. When the repetition is allowed, then the such type of the arrangement is n raised to r. Next, the number of arrangement of n different objects taken all at a time when two specified objects are always come together is 2 in bracket n minus 1 factorial, 2 specified object. Now see this, the proof of this. Let 2 specified objects be considered as one single object. Then, if we take the two objects and treat it as a single object, then now we have n minus 1 different objects, because first of all we have n object, and if we take the 2 and that 2 treated as a single one, then what will the total one? The total one is n minus 1 different objects which can be arranged among themselves. That is, suppose that if we have the 5 object and if we take the 2 from that object, then the remaining will be 3, and the 2 object taken as the single one, then total objects will be the 3 plus 1, 4. In the same way, two specified objects be considered as a single object. Therefore, now we have n minus 1 different objects which can be arranged among themselves in n minus 1 factorial ways. After this is done, two specified objects can be arranged among themselves in 2 factorial, that is 2 ways, using fundamental principle, that is, we have the product of these two terms, the total number of arrangement in which two specified objects always come together, 2 in bracket n minus 1 factorial. When the two specified objects are taken from the n objects, then the arrangement is a 2 in bracket n minus 1 factorial. The number of permutations of n different objects taken all at a time when two specified objects never come together is n minus 2 into n minus 1 factorial. Two specified objects never come together. The number of permutations of n different objects taken all at a time when no restriction is imposed is n factorial. No restriction. Now from this n object, suppose that if we take the two specified object and out of which 2 in bracket n minus 1 factorial permutations contains two specified objects always together. Hence, if we subtract, hence in the remaining permutations, that is n factorial minus 2 in bracket n minus 1 factorial, that is a n into n minus 1 factorial minus 2. That is, we have arranged here n factorial means what? N into n minus 1 factorial, and now we can take n minus 1 factorial as a common. Therefore, in bracket you will get n minus 2, in second bracket n minus 1 factorial. See this here. That is a n minus 2 in bracket n minus 1 factorial. Therefore, the permutations two specified objects never come together next. The number of permutations of n different objects taken all at a time when m specified objects always come together is, that is, m specified object can be written as m factorial into n minus 1 plus 1 factorial. These are the formulas that you have to remember. I will apply all these type of the formulas when our exercise will start. The number of permutations of n different objects taken are at a time when particular object is to be always included in each arrangement is r into n minus 1 into r minus 1. The number of the permutation of n different taken r at a time. Next, the number of permutations of n different objects taken are at a time when particular when particular object is never included in each arrangement is n minus 1 p r. Next is, now we will start the exercise here 3.3. So this is a very big exercise. Now first example, find n if np6 as to np3 is equals to 120 as to 1. Now np6 upon np3 is equals to 120 upon 1. Now we apply here formula n factorial upon n minus r factorial, that is n factorial upon n minus 6 factorial upon n factorial upon n minus 3 factorial, that is equals to 120 upon 2. This is very simple. We have applied the formula. Now this n factorial can be extended, that is, or this will be the multiplied and the reciprocal, and we arrange like this. N minus 6 factorial into n minus 3 factorial into n factorial, that is 120 upon 1. Now this n factorial get cancelled. Therefore, n minus 3 into n minus 4 into n minus 5 into n minus 6 factorial upon n minus 6 factorial is equals to 120. N minus 6 get cancelled. You will get n minus 3, n minus 4, n minus 5 is equals to 120. Now there are the three consecutive numbers whose product is 120. That you have to find out now. Then what are such numbers? That is 6, 5, 4. Now if we compare these, n minus 3 is equals to this, we want to find out by trial and error. We want to find out the three consecutive numbers whose product is 120. N minus 3 is equals to 6, therefore n is equals to 6 plus 3 is equals to 9. Second question. Find m and n if m plus n p2 is equals to 56 and m minus n p2 is equals to 12. Therefore, m plus n p2 is equals to 56, and now this can be written as like this: m plus n factorial upon m plus n minus 2 factorial is equals to 56. Now we can simplify. It is like this: m plus n minus 1, m plus n minus 2 factorial upon m plus n minus 2 factorial is equals to 56, and these two terms get cancelled. That is equals to 56. M plus n treated as another letter, and if we take m plus n is equals to x, then the equation will be x in bracket x minus 1 is equals to 56. X square minus x minus 56 is equals to 0. And now this can be factorized as x square minus 8x plus 7x minus 56 is equals to 0. X in bracket x minus 8 plus 7 in bracket x minus 8 is equals to 0. Therefore, x minus 8 into x plus 7, that is equals to 0. X minus 8 is equals to 0, or x plus 7 is equals to 0. X is equals to 8, or x is equals to minus 7. X is equals to minus 7 is not possible. Therefore, we take x is equals to 8. That is not possible. Therefore, m plus 7 is equals to 8. Also, we have that is m plus n is equals to, I will change that. Now next, m minus n p2 is equals to 12. Now again, this can be written as m minus n factorial upon m minus n minus 2 factorial. We can cancel it. See this if you want to see. M minus n factorial can be written as m minus n minus 1, m minus n minus 2 factorial, and now these two terms get cancelled. Now we want to solve this. M minus n is equals to y. Then it will become the quadratic equation like this. See this here. That is m minus n is equals to 1. Therefore, y in bracket y minus 1 is equals to 12. That is y square minus y minus 12 is equals to 0. Therefore, y minus 4 in first bracket, second bracket y plus 3 is equals to 0. This is very simple quadratic equation. Therefore, y minus 4 is equals to 0 and y plus 3 is equals to 0. Or y plus 3 is equals to 0. Therefore, y is equals to 4 or y is equals to minus 3. Now here, what is the value of y? Y is m minus n is equals to 4. This is the, and m minus n is equals to minus 3, and m minus n is equals to minus 3. Again, it is a minus, which is not possible. Therefore, we take m minus n is equals to 4. And now we'll solve these two equations. Now I will change here. What is that? M plus n is equals to 8. This is equation number 1. M plus n is equals to 8 and m minus n is equals to 4. Therefore, from 1 and 2, m plus n is equals to 8 and m minus n, m minus n is equals to 4. If you add these two equations, then 2m is equals to 12. Therefore, m is equals to 12 upon 2. That is equals to 6. Put m is equals to 6 in any one of these two equations. Therefore, you will get m plus n is equals to 8. 6 plus n is equals to 8. Therefore, n is equals to 8 minus 6. That is equals to 2. N is equals to 2. Now, next is m is equals to 6 and n is equals to 2. Now, next question. Question number 3. Find R if 12p r minus 2 as to 11p r minus 1 is equals to 3 as to 40. Now 12p r minus 2 as to 11p r minus 2 is equals to 3 as to 40. Therefore, it is written as like this. Now simplify these two terms. There is a 12 factorial upon 12 minus r minus 2 factorial. This whole divided by 11 factorial upon 11 minus in bracket r minus 1 factorial. That is equals to 3 upon 14. Now simplify this. 12 factorial upon 11 factorial. These are the numerical. And 11 minus r minus 1 factorial. 12 minus in bracket r minus 2 factorial is equals to 3 upon 14. Now 12 factorial can be written as 12 into 11 upon 11 factorial. And if we simplify this, 11 minus r plus 1 factorial and denominator 12 minus r plus 2 factorial is equals to, we can write like this now here. Now here is a 11 plus 1, that will be 12, and 12 plus 2, that will be the 14. See this here. That is 12 into 11 plus 1 minus r factorial, and 12 plus, that is a 14 minus r factorial, 3 upon 14. 12 into in bracket 12 minus r factorial upon 14 minus r factorial is equals to 3 upon 14. Now we'll simplify here. 12 into 12 minus r factorial upon 14 minus r, 13 minus r, 12 minus r factorial. And in this case 3 upon 14. Now 12 minus r get cancelled. You can write this is okay. Now next is, we'll simplify this. That is a 4 upon 14 minus r in bracket 13 minus r is equals to 1 upon 14. Therefore 56, that is equals to 56. Now we'll simplify this here. That is 56 can be written as, there are the two consecutive terms whose product is, that is 8 into 7, and big one is 14 minus r, that is equals to 8. Therefore r is equals to 14 minus 8, and that is equals to, r is equals to 6. Now next is question number 1. Show that n plus 1 into npr is equals to n minus r plus 1 in bracket n plus 1 pr. Now we'll take first of all LHS and solve up to some extent. That is n plus 1 into npr can be written as n factorial upon n minus r factorial. Now again this can be written as like this, n plus 1 factorial into n minus r factorial. This is number 1. And RHS, n minus r plus 1 factorial, n plus 1 pr, that is equals to n minus r plus 1 into n plus 1 factorial upon n plus 1 minus r factorial. Therefore n minus r plus 1 into n plus 1 factorial upon n minus r plus 1 factorial, n minus r plus 1 into n plus 1 upon n minus r plus 1 into n minus r factorial. That is here n minus r plus 1 get cancelled, and you will get the similar terms. Therefore, from 1 and 2, LHS is equals to RHS. Hence, the result is proved. Now, the next question number 5. How many 4-letter words can be formed using letters in the word Madhuri if first letters can be repeated, second letters cannot be repeated. Now there are 7 different letters in the word Madhuri, and we have to form 4 letters word, that is n is equals to 7, r is equals to 4, the first letter can be 7 times. Repetition is allowed there, that is 7 raised to 4. Also, when repetition of letters is allowed, then the total number of 4-letter word, that is n raised to r, that is 7 raised to r means, and it is like this. Therefore, the answer is 2401. Now, second, if the repetition of letters is not allowed, then it is very simple. That is a NPR, n factorial upon n minus r factorial. That is it. Then the number of 4-letter word, that is NPR, is equals to 7p4, 7 factorial upon 7 minus 4 factorial. That is equals to 7 factorial upon 3 factorial. 7 into 6 into 5 into 4 into 3 factorial upon 3 factorial. These two get cancelled, and you will get 840 when the repetition is not allowed. Now the next question number 6. Determine the number of arrangements of letters of the word algorithm if vowels are always together. B. No two vowels are together. And C. Consonants are at even positions. D. O is the first and T is the last letter. You see this? The number of letters in the word algorithm is 9. Vowels are A, O, I. That is, there are the 3. And the consonant. They are L, G, R, T, H, N. That is 6. Now the first, vowels are always together. Now vowels are A, O, I. Consider an as one letter and consonant are 6. That is a total is equals to 6 plus 1 and that is equals to 7. Three vowels can be arranged in 3 factorial ways. That is, 3 factorial means what? 3 into 2 into 1 and that is equals to 6 ways. And word forming seven can be arranged in 7p7. That is equals to 7 factorial upon 7 minus 7 factorial. That is a 0 factorial means what 1 and it is a 7 factorial. Therefore, 7p7 is 7 factorial. Hence, total number of words from using vowels are together. That is a 3 factorial into 7p7. That is equals to 6 into 5040, that is equals to 30240, 30,240. When that is a we can form 3,240 when the OLs are together. Now next, second, no two OLs are together. Now also this is very nice example. Now see these are the constant and total they are 6. Now OLs are occupying this position. Now count it. In above, OLs can be placed in 7 positions. If we count it, you will get 1, 2, 3, 4, 5, 6, 7. 7 positions and 3 OLs. Therefore, they can be arranged 7p3. That is a 3 OLs is remaining there. That is 3 OLs can be placed in 7 position. That is a 7p3 there must be there. The constant can be arranged in 6p6 ways. Hence, the OLs can be arranged in the 7 position. 3 OLs are there. Here is must be 3. Hence, the total number of words in which 2 OLs are together now here I forget to write here, that is the OLs are not together, therefore it is written as 7p3 into 6p6. Now see this here. And that is equals to 1,51,200. Therefore, we can form one lakh 51,200 words in which no 2 OLs are together. That is, in word algorithm, That is, in the last example, no two words are together, and 7p3, you can change it when you write the answer of that example. Now the third part. In word algorithm, that is, the even positions are 4, that is a 2, 4, 6 set, and the consonant are 6. That is, the consonant are at the even position. Therefore, the number of arrangements in which six consonant occupy 4 even positions, that is a 6p4. Now the remaining 5 positions. In remaining 5 positions, there will be the 2 consonant and 3 vowels. 5 letters, that is a 5p5 ways. Therefore, the total number of words in which consonant occupy even positions, that is equals to 6p4 into 5p5, that is a 6 factorial upon 6 minus 4 factorial into 5p5, 5 factorial upon 5 minus 5 factorial, that is equals to 6 factorial upon 2 factorial into 5 factorial upon 0 factorial, and it is a 6 into 5 into 4 into 3 into 2 factorial upon 2 factorial into 5, 4 into 3 into 2 into 1, and we can simplify. That is 360 into 120. That is equals to 43,200. Next is D. O is the first and T is the last letter. Now this is very simple. Total 9 boxes will be there. Okay. O is first and T is last. Now the remaining 7 can be arranged in 7p7 ways. Therefore, the first position is O and last position is T. Remaining 7 positions is a very simple problem. Remaining 7 positions can be arranged in 7p7 ways. That is 7 factorial upon 7 minus 7 factorial. That is equals to 7 factorial upon 0. That is 7 factorial. That is equals to 7 into 6 into 5 into 4 into 3 into 2 into 1. and you can perform this multiplication. That is 5040. The words can be formed. If O is the first and T is the last letter. Now, question number 7. When a group photograph is taken, all 6 teachers should be in the first row and all 18 students consisting of 12 boys and 6 girls should be in the second row, such that no 2 girls are together. If the middle seat of the first row is reserved for the principal, how many arrangements are possible? How many such arrangements are possible? Now here 6 teachers and 1 principal in first row. 12 boys and 6 girls are in the second row. For first row, in middle position there is a principal, and on the both sides 3 teachers are there. Now this can be arranged in 6p6 ways. That is the position of principal is fixed. The remaining 6 positions, that is 6 teachers, can be arranged in 6p6 ways. In second row, that is a total 18 students, 12 boys and 6 girls. Now we have the positions in blue mark, there are the girls. That is, no two girls are sit together. They have 11 places between the 12 boys. They are marked in the blue markers there. And the 2 places at the 2 ends as shown above. Now see this total. Therefore, 13 positions are for the 6 girls. 13 positions for the 6 girls can be arranged in 13p6 ways. That is it. And the 12 positions for 12 students can be arranged (12p12) ways. Hence, the total number possible for possible arrangement for a group photograph is equals to 6p6, that is for the teachers, 13p6 for the girls, and 12p12 for the boys. And it can be written as 6 factorial upon 6 minus 6 factorial, 13 factorial upon 13 minus 6 factorial into 12 factorial upon 12 minus 12 factorial. That is 6 factorial upon 0 factorial, 13 factorial upon that is the 7 factorial, 12 factorial upon 0 factorial, 0 factorial is always 1, but I am writing there always. And now we will simplify here, that is the 12 factorial into 13 factorial upon 7. This is the arrangement for the photograph. Now next. Now the question number 8. Find the number of the ways so that letters of the word history can be arranged as first Y and T are together. See this here. In the word history, the number of letters are n is equals to 7 and Y and T are together. Considering Y and T as one unit, and remaining are 5. Total is equals to 1 plus 5, that is equals to 6. These 6 can be arranged 6p6 ways and y and t can be arranged themselves in 2p2 ways. Hence, the total number of words formed in which y and t are always together is given by six p6 into 2p2, that is equals to 6 factorial upon 6 minus 6 minus 6 factorial into 2p2 means what? 2 factorial upon 2 minus 2 factorial, that is a 6 factorial upon 0 factorial into 2 factorial upon 0, that is 6 factorial into 2 factorial, that is 6 into 5 into 4 into 3 into 2 into 1, 2 into 1, and that is equals to 1440 words can be formed if y and t are together. In second case, y is next to t. Since y is always next to t, consider ty as a single unit where their product is fixed. So we have this unit as a 1 and the remaining 5. Therefore, the total 1 plus 5 is equals to 6. That can be arranged in 6p6 ways. That is equals to 6 factorial, and it is written as 6 into 5 into 4 into 3 into 2 into 1, that is 720 words can be formed when y is next to t. Next, there is no restriction that is these 7 letters, as there is no restriction, 7 letters can be arranged as 7p7 ways. 7 letters can be arranged in 7p7 ways. That is 7 factorial upon 7 minus 7 factorial, that is equals to, overall it is a 7 factorial, and that is a, we can arrange when there is no restriction, that is 7 factorial words can be arranged when there is no restriction. THRE, there must be THRE. Next, D part. Begin and end with vowel. Now in the word history, see this. First is consonant, then vowels, consonant. Here vowels are I, O, therefore, and last is vowels. Therefore, two vowels can be arranged in 2p2 ways and can be arranged in 2p2 ways. And the 5 constant remaining can be arranged in 5p5 ways. Therefore, total number of words 5p5 into 2p2. I had written here 5 is wrong, placed there. There must be 2 here. That is a 5 factorial into 2 factorial. 5 into 4 into 3 into 2 into 1 into 2. And therefore, its product is 240. Therefore, the number of words are 240. Next is end in ST. Now see this here. HIO, RY, and the last is end with the ST. Now these 5 letters can be arranged in 5p5 ways. Therefore, five factorial upon 5 minus 5 factorial, that is equals to 5 factorial. 5 into 4 into 3 into 2 into 1, that is equals to 120. Therefore, the 120 words can be formed when it ends with the ST. Next is begin with S and end with T. Therefore, our total are 7 and the remaining 5 position can be written as 5p5 ways. Therefore, this is also very simple. Begin with S and end with T. The remaining letters can be arranged 5 ways. Therefore, the total number of words 5 factorial upon 5 minus 5 factorial, and overall it is a 5 into 4 into 3 into 2 into 1, that is equals to 120 words can be formed when begin with and end with T. Now the question number 9. The number of arrangements of the letters in the word Solapur so that consonants and vowels are always placed together and vowels are placed alternately. Solapur so that the consonant and the vowels are placed alternately. Now see this Solapur and C for the consonant and B for the vowels. There are 4 consonants. They can be arranged in 4p4 ways, and vowels can be arranged in 3p3 ways. Therefore, total number of words when consonant and vowels are placed alternately, that is a 4p4 into 3p3, that is a 4 factorial upon 4 minus 4 factorial into 3 factorial upon 3 minus 3 factorial, and overall it is a 4 factorial into 3 factorial, that is 4 into 3 into 2 into 1 and 3 into 2 into 1, that is equals to 144 ways. That 144 words can be formed where the vowels and consonant are placed alternately. Now next is find the number of 4-digit numbers that can be formed using digits 1, 2, 3, 4, 5, 6, 8 if digits can be repeated repeated. Second, digits cannot be repeated. If there are n digits, and to form r digits number, then first, that is, digits are repeated, that is A part. Now in this case, then the total number of the numbers is equals to n raised to r. The digits are repeated, and if the digits are not repeated, then it is written as NPR. These are the important formulas for this. NPR. Therefore, hence here n is equals to 6, r is equals to 4. Therefore, the total number of the number is equals to n raised to r, that is 6 raised to 6, sorry, 6 raised to 4, and it is written as 6 into 6 into 6. 6, that is 4 times, that is 1296. Now next, the digits cannot be repeated. Then it is a NPR, that is a 6P4, that is equals to 6 factorial upon 6 minus 4 factorial, 6 factorial upon 2 factorial, that is 6 into 5 into 4 into 3 into 2 upon 2 factorial, and their multiplication. That is equals to 360. Ways. The numbers can be formed when the digits cannot be repeated. Now the question number 11. How many numbers can be formed using the digits 0, 1, 2, 3, 4, 5 without repetition, so that the resulting numbers are between 100 and 1000. Now we have the digits 0, 1, 2, 3, 4, 5 and the numbers between the 100 and 1000. The numbers between 100 and 1000 that is that the numbers are from 101 to 999. By using the digits 0, 1, 2, 3, 4, 5, For the 100 place, we can select 1, 2, 3, 4, 5. The number of ways are 5p1. For the 10 place, the number of ways are, that is 6p1. And for the unit place, that will be the selection of digits 4p1. Therefore, total number of numbers between 100 and 1000 is equals to 5p1 into 5p1 into 4p1. That is 5 into 5 into 4, and that is equals to 100. Therefore, the 100 numbers can be formed between 100 and 1000. Now, second, find the number of 6-digit number using the digits 3, 4, 5, 6, 7, 8 without repetition. That is 6-digit number form without repetition. How many of these numbers are divisible 5, and second is not divisible by 5. If there are n digits, and n digit number is to be formed without repetition, the number of numbers are npn, that is a n factorial upon n minus n factorial, that is n factorial upon 0 factorial, that is equals to n factorial. Hence, n is equals to 6, that is a 6-digit number. Problem with the pen. 6-digit number is to form. Therefore, the number of ways is 6p6. That is 6 factorial upon 6 factorial, 6 minus 6 factorial, and that is overall it is equals to 6 factorial. That is 6 into 5 into 4 into 3 into 2 into 1. That is 720. Whence the number can be formed. Now the first part, the number is divisible by 5. When the number is divisible by 5, then its unit place must be 5. This is the one way. And the remaining 5 places, unit place 5p 5 ways. That is when the number is divisible by 5, total number is equals to 5p5 into 1. That is 5 factorial upon 5 minus 5 factorial into 5 factorial upon 0 factorial, and overall it is a 5 factorial. Therefore 5 into 4 into 3 into 2 into 1, and that is equals to 120. Therefore there are the 120 numbers in which are divisible by 5. Next is B, not divisible by 5. That is all the numbers minus the numbers which are divisible by 5. This we can solve like this also. That is all numbers 720 minus 120. That is total numbers minus the numbers which are divisible by 5. Which are divisible by 5. That is 720 minus 120, that is equals to 600. (600) are the numbers which are not divisible by 5. The problem number 13. A code word is formed by two different English letters followed by two non-zero distinct digits. Find the number that is the first letter is from the English letter, and they are followed by the non-zero distinct digits. Find the number of such code words that end with an even digit. Now see this here. Here we want to form the code like this. This is only the for example. Suppose that it is MH12. These are the English, and they are followed by the numericals, non-zero numericals, for example the 12. Now see this, how we can form. There are 26 alphabets and 9 digits from 1 to 9. Non-zero digits the first is For a code two distinct alphabet can be arranged in 26 P2 ways and two digits, that is a 9 P2 ways. Hence, total number of code words available, that is a 26 P2 into 9 P2, that is 26 factorial upon 26 minus 2 factorial into 26 factorial upon 24 factorial into 9 factorial upon 7 factorial, and it is written as like this: 26 into 25 into 24 upon 24 factorial, 9 into 8 into 7 factorial upon 7 factorial, that get cancelled, 24, 24, 7, 7, and therefore their product is 46,800. Now this can be found. Now we require the even number at the end. Now the code end with even digit. First, that is the first part of code is two distinct alphabet. That is can be arranged, that is 26 P2 ways. Therefore, for the second part, unit place must be even digit. That is 10 place and unit place. Now for unit place, we can select 2, 4, 6, 8. That is 4 digits. And for the 10th place, remaining 8 digits. Therefore, the total number of code words that end with an even integer is, that is a 26 P2 and into 4 into 8. That is a 26 factorial upon 26 minus 2 factorial into 4 into 8. That is 26 upon 20, 26 factorial upon 24 factorial into 32. And we can cancel these terms. Now this normal cancellations is there. That is 20,800. The number of code words that end with an even digit is 20,800. Now the question number 14. Find the number of ways in which 5 letters can be posted in 3 post boxes. If any number of letters can be posted in a post box. Now we have the 5 letters. Now we have first 5 letters, that is L1, L2, L3, L4, L5, and the boxes are B1, B2, B3. Now for the letter 1, L1, L2, L3, L4, L5, and the boxes are. Now the first letter can be filled any one of the box, can be posted in any one of the box. That is, we can fill 3 types, can be posted. The second letter can be posted in any one of the box. That is, again we can put in B1, B2, B3. That is, we have the again 3 ways. Third, L3, third letter can be posted in any one of boxes. That is 3 ways. L4, that is the fourth letter, can be posted in any one of the boxes. That is again the 3 ways. And the L5, the fifth letter, can be posted any one of boxes. That is 3 ways. Therefore B1, B2, B3, L1, that is, we can post it in 3 ways. L2 in 3 ways. L3 we can post in the box, that is 3 ways. L4, L5. Therefore the total ways are 3 into 3 into 3 into, that is a 5 times multiplication. That is a 3 raised to, therefore the total number of ways of posting 5 letters in 3 boxes are 3 into 3 into 3 into 3 into 3, that is equals to 3 raised to 5, that is a 243. That we can place in 243 ways. Find the number of arranging 11 distinct objects taken 4 at a time, so that a specified object, that is, find the number of arranging 11 distinct objects taken 4 at a time, so that a specified object always occur, never occur. Now again, this is by using the formula again. The number of permutations of n distinct objects taken are at a time when a specified object is always to be included is r into n minus r p r minus 1. First, keep the specified object aside. Arrange r minus 1 from the remaining n minus 1 object, that is a n minus 1 p r minus 1 weights. Then place the specified object in r possible weights. Hence, the total number arrangement is r into n minus 1 p r minus 1. Here r is equals to 4, n is equals to 11. That is 4 into 11 minus 1 into p, that is 10 p 3 ways. That is a 4 into 10 factorial upon 7 factorial, and we can find out its values. That is equals to 4 into 10 into 9 into 8. Now the second part, the number of permutation of n distinct objects taken are at a time when a specified object is not be included in any permutations is n minus 1 p r. That is n minus 1 p r, 11 minus 1 p 4, that is a 10 p 4, and that is equals to 10 factorial upon 10 minus 4 factorial, 10 factorial upon 6 factorial, 10 into 9 into 8 into 7 into 6 factorial. Now these two get cancelled. Now there is a simple multiplication. 10 into 9 into 8 into 7, that is 5040. That is, we can see this answer again. . and multiplication. This is the answer. Now next problem. That is the problem number 16. In how many ways can 5 different be arranged on a shelf if there are no restriction? First is n is equals to 5, r is equals to also 5. Therefore, they can be arranged in 5p 5 ways, that is a 5 factorial upon 5 minus 5 factorial upon, that is equals to 5 factorial upon 0 factorial, that is 5 factorial. And their multiplication is 120 ways. That is 5 different books can be arranged in 120 ways if no restriction now the next is 2 books are always together. Now see this here. The number of permutations of n distinct objects taken all at a time when 2 specified objects are always together is 2 in bracket n minus 1 factorial. This is the formula that I had given at the starting of this video. N is equals to 5. Therefore, required answer is, that is the required arrangement is equals to 2 in bracket n minus 1, that is 5 minus 1 factorial, that is a 2 into 4 factorial, that is equals to 2 into 4 into 3 into 2 into 1, that is equals to 48. Now the next is two books are never together. That is a NPN minus 2 in bracket n minus 1 factorial. Now we can, by using this formula, we can find out it. That is 5p5, that is all type of the arrangement. And when the two books are always together, that is a 2 in bracket n minus 1 factorial. If you subtract it, then you will get the answer of this problem. That is 5 factorial upon 0 factorial minus 2 into 4 into 3 into 2 into 1. I am always writing by using this formula, that is 120 minus 48, that is equals to 72 ways. Now the next is problem number 17. 3 boys and 3 girls are to sit in a row. How many ways can this be done if 1. There are no restrictions. Therefore, as there is no restrictions, that is 3 plus 3 is equals to 6, and that is n is equals to 6, r is equals to 6, and they can be arranged. The required arrangement is 6p 6 ways. That is 6 factorial upon 6 minus 6 factorial. That is a 6 factorial. 6 into 5 into 4 into 3 into 2 into 1. That is equals to 720 ways, as there is no restriction. Now in second case, there is a girl at each end. Now see this. The total is 6, G and G, and the remaining 4 places. Three girls at each end can be done. That is a 3p2 ways. And the remaining 4 places can be filled with 4 boys and 1 girl. Is 4p 4 ways. Therefore, the required number of arrangement is equals to 3p2 into 4p4 ways. That is equals to 3 factorial upon 3 minus 2 factorial into 4p4 means what? 4 factorial upon 4 minus 4 factorial. That is equals to 3 factorial upon 1 factorial into 4 factorial upon 0 factorial. 3 factorial into 4 factorial. That is a 3 into 2 into 1, 4 into 3 into 2 into 1. That is equals to 144 ways. Therefore, the required number of arrangement can be done in 144 ways. Now, third is boys and girls are at alternate places. Now see this position. They have the total 6. First G, B, G, B, G, and the B. Now this can be done in 3p3 and 3p3 ways. Or in second position, they can be written as starting with boys, that is 3p3. Boys can be places 3p3, girls can be places in 3p3 ways. Therefore, the required arrangement, that is equals to 2 into 3p3 into, if you add these two, then you will get 2 into 3p3 into 3p3. And that is equals to 2 into 3 factorial upon 3 minus 3 factorial into 3 factorial upon 3 minus 3 factorial. And that is equals to 2 into 3 factorial into 3 factorial. That is equals to 2 into 3 into 2 into 1, 3 into 2 into 1, that is equals to 1. If we perform their multiplication, (72) ways. The next is all boys sit together. It means G1, G2, G3 and B1, B2, B3 is treated as a 1 unit, and 3 girls, that is a 1 plus 1 plus 1, that is total is 4, that is 1 unit plus 1 plus 1, that is a total 4. These can be arranged. This can be arranged in 4p4 ways. Also, all these 3 boys, that is a B1, B2, can be arranged G1, G2, that is a girls, 3 girls can be arranged in 3p3 ways. Therefore, the total number of the ways are 4p4 into 3p3 ways. That is 3 boys treated as 1 unit. Therefore, 3 factorial into 4 factorial, and that is equals to 144. Therefore, the required number of arrangement, that is the required number of the ways, is equals to 7. 144 ways. In this way, we have completed this exercise 3.3. I hope that you have understood all the problems. I will see you in the next video. Till then, goodbye. In this way, we have completed this exercise, that is a 3.3. I hope that you understood all the solutions of these problems. Now we'll see in the next video. Till then, goodbye.